So that your career will be very good in this section, because there is a large demand of coastal specialist and urban specialist. As your background is from geography, so it is very much fitted to this, and a lot of opportunities are there also in this sector. So, and another thing is, if you are interested, then you can some basic knowledge about some programming, like Google Earth Engine, or some data analysis softwares are there.
Yes,
So
sir.
that your profile will be very good in future,
Okay, sir.
because your experience already 3 year experience is there,
Yes, sir.
and your qualification is very good. Now you are working in a government organization or private one?
Now I can government organization, sir, in
You
March.
know about NCSCM, National Center for Sustainable Coastal Management.
Yes, sir.
So try to apply in this organization. So you have a lot of experience. So they will hire you because they need some specialist, and you have a geography background. And every year there is an opportunity in NCSM, because we are recently collaborate with NCSM and for coastal studies. So I know about the organization. So you ever tried in this organization or not?
No, sir. I not tried the still no. I will try, sir.
Okay, just tried. Just search. One is for NCSM, and another is NCCR, that is National Center for Coastal Research. These are a good organization which are situated in only in Chennai.
Okay,
So
sir.
this is the good experience if you are interested. So if any vacancies are there, then I will provide in this WhatsApp group any type of JS and other vacancies are there.
Yeah,
Okay.
okay. Okay, sir. Thank you, sir.
Okay. And your certificate for this exam certificate also very much helpful in your future
Yes, sir.
growth. Go through this, and after the closing of the theory, then practical season may be provided by you nearby your regional center, I think, because
Yeah, okay, sir.
all practical are not possible in online mode, no?
Yeah, sir. Sir, if practical exam means I where conducting the practical exam, like, exam means, sir.
Practical exam previously, I was also conducted a different practical exam. So in the practical exam, there are some, it's not lot of difficult. Some are some georeferencing techniques, some classifications, like this type of practicals are there.
Sir,
So
actually, I am belong to Chennai region, RC Chennai.
okay.
So, practical second means I'm going to attend the Chennai or some other place.
No, practical will be attended in the Chennai, because it is not possible to attend practical outside of your state.
Oh, okay, sir.
So it is very difficult. So you try to contact with your regional center for this practical, because practical will be, I think, after 1 month or 2 months it will be started
Okay, sir.
before the exam.
Yeah,
So
yes.
we will schedule for another season for practical, maybe.
Hmm.
So I am not aware of this schedule. If possible, then I will send you.
Okay, sir.
Okay. So now, currently, which area you are working?
Sir, I'm again census department.
Census department in Chennai.
Yeah, yes.
Okay. But census department in Chennai, we have some experience in only database related issue, and some political maps, and
Yes, so they are preparing for language atlas and some
uh,
other
only
census
mapping
related,
purpose. But
population related maps and other things, sir.
so try to explore different thematic region, like urban sprawling
Yeah, yes,
and
sir.
coastal research, so that your expertise will be enhanced and you can get more opportunity.
Yes, sir.
Okay, so just looking for all this, if you have better career, otherwise you are in good organization. It's not a bad organization,
Yes, sir.
but sometimes it's look like sometimes gives you some frustration that it's doing all time doing repeated work. That's the one thing.
Yes, sir.
So human needs some more new things and know to want to know more things. Work for different sector.
Yeah, they are preparing for ward level maps to district level maps and administrative maps like
Hmm.
that.
So they need every month they need the different maps or for near the election time or in the survey time.
In state government already prepared for the maps, sir, election time.
Okay.
In the purpose of census, they collect to state government to the office, bring
Hmm.
the all maps to. They are given to soft copy,
So
soft documents.
actually, I want to know one thing. So the next census for 2021, already the survey work is already processed, or it's need to
No, sir.
be
Still, I think postponed. I think I don't know, sir. That detail.
okay, okay, because you are in census.
They
So,
told 2024 they're conducting census, but I don't know, sir.
okay,
125 or opposite.
so
Maybe
that
next week.
our census for 2021 will be in 2027
Maybe, sir.
because it takes 2 years minimum.
Yeah, sir.
That time we have a large responsibility.
Yeah, yes, sir. After 5 years, they conducting census now, so getting more
So
trouble and
you have to conduct a lot of data
yeah,
and
yes, sir.
a lot of information.
Hmm.
Okay, then we'll start our session
Yes.
now. Okay. Now the slide is visible now.
Yes, sir. Visible, sir.
Okay. So now, now the topic is today's topic is the remote sensing's multivariate image statistics and how the different bands and behave with the different features and how to get a new information within this processing of different bands. So, the processing of multivariate statistics measures such as covariance and correlation among the several bands, like the features like band ratio. So, band ratio is one of the technique that for single band like blue band or green or red band. So, these are calculated with respect to the different ratios, then get the output. So this output is very much helpful for different analysis. Then another thing is principal component analysis. So different components in the different axes of the images are created so that the different features are clearly visible. So classification and accuracy assessment, these are all needed for the multivariate image statistics. So in this spectrum details, so visible lesion like blue, green, red, these are the bands which are ranges from zero point 0.4 micrometer to 0.67 micrometers, which are absorb more chlorophylls in this region. So visible lesion absorbs more so that it reflects less, and in the near infrared region the vegetations and all the green components are reflect more and absorb less, so that the less absorption or high absorption ratios are calculated using different band ratios so that the different images are created and after creating this image we can calculate then what is the range of our vegetation, what is the health of our vegetation, what is the water body contents. So for different application, different ratios, different bands are used to calculate different resultant. So in the short wave infrared, which is higher than the near infrared region, the atmospheric water absorption bands are there. So these are different applications. So that's why in our satellite image, there is only visible region is not recorded. Out of this, the near infrared, short wave infrareds, spectral bands are used. A lot of in the all of the images are present to calculate different indices and to reflect the clarity of the image. So this is the band ratio techniques, and after that, different components of the principal axis are also used. So we'll go step by step. So healthy vegetations reflect strongly in the near infrared, which are already told in this previous slides. So other surface like soil, water, so near the equal reflectance in both near infrared and red portions. The ratio of image from 0 to 1.8 micrometer, which is in the near in the infrared band divided by red band, would result in ratio much greater than 1 for vegetations. So these are the calculations. Thus, the discrimination of vegetations from other surface cover paths is significantly enhanced. So we are better able to identify area of unhealthy and stress vegetations. So these are the bands of sentinel and data. Coastal bands are there: blue, green, yellow, red. Red is near infrared 2. So there are various applications in this band. So there are very sensitive to specific band of the different features of the Earth surface. That's why we use different bandwidth of different spectral bands to analyze different application, like coastal band, which is useful for coastal application, water penetration, deep water mask, material and differentiations, shadow tree water differentiations, blue band, that is coastal application, water body penetration, soil vegetation, forest type, reef covers, then green vegetation, that is crop type, seagrass, salt marsh, and bathymetry. Yellow veins leaf coloring, like all algal blooms, seagrass and reefs also identified. Then red, that is very much useful for chlorophyll absorption, vegetation analysis. Red edge, that is more bandwidth as compared to the red, and vegetation health, stress type. Then most of the important band is the near infrared band, that is biomass survey, plant stress, and delineation of water bodies, because water bodies looks like very dark in the near infrared, but in the other bands it is uh, uh, slightly in dark. So the land part and water bodies are clearly demarcated using the near infrared bands. Then near infrared to biomass survey plant trees. So this is the infrared band. There is the red band. Then ratios are infrared and by red. So it is the final product. So I just show you in the my image. So these are some bands uh, of Lancet 8. So previously I just so that the how to identify the satellite image. So this is the satellite image name LC Lancet 08. Then the date of the acquisition of the satellite data, like 15 March 2015 is written here in the file. So all these informations are there, and it is a tier level 1 satellite image. So there are three satellite image, that is level 0, level 1, and level 2. Level 2 is uh, atmospheric corrected satellite image, and level 1 is a rectified satellite image, and the level 2 is the raw data. So it is not a raw data, so some corrections are there in the level 1. So these are all level 1 data which is freely available. So this is the band 2 satellite image of Landsat 8. So it is, the water bodies are not clearly visible in this band. So the Landsat 5 is the infrared band, which is clearly visible the water content. So it is clearly dark, that signifies that it absorbs more in the water areas or water bodies, so that the demarcation of land and water is very much clear in this band. So basically it is mostly used in our coastal studies like shoreline demarcations, and flood inundation area also it is demarcated. That is infrared band. Then this is the, it is a near infrared band. It is also looks like a very dark tone of the water bodies and reservoirs. So I just choose some band 2, 4, 5, 6, and band 3 of different spectra. So now the band ratio. Why you use the band ratio? The band ratio of two bands removes much of the effect of illumination in the analysis of spectral differences, and this is possible because of the composition of difference between two geological units, or some different geological features are there, different land features are there of having different land use land covers. The area with significant haze and performance ratio is much improved by removing the haze and produced by relay scattering in the atmosphere. So this is the single band. Then it is the band ratio, that is band 3 by band 2 of a Landsat image. So in this first image, there is no differentiation of the different rocks, but in this band ratio, there is a differentiation of the different type of rocks. Like this is the brighter tone and this is a darker tone. So band ratio is differentiate based on their chemical compositions or different vegetations and soil characteristics. So these are the identification features which can differentiate based on the different band ratio. This is also one of the band, single band and double band. Then it is a red, green, blue. That is the three color composition band. That is one band is 3:2, three band 3 by band 2, second is band 5 by band 2, then third is band 7 by band 4. So these all bands are joined, so that the different geological structure and different minerals are demarcated based on this segregation of all the geological features. So, Venn ratio sometimes clearly identified the different rock types, different minerals, and in the also in the vegetations, different forest areas, and also in the different water bodies and shoreline change. So it has a lot of applications based on their uh, bandwidth and the resolution of this satellite image. If there is a high resolution satellite image having different band, so the band ratio is very much accurate and very much clear, and it demarcate very accurately. So if you will take 30-meter or 15-meter resolution satellite image, so it may some missing of the data. So this is also one of the image that is near infrared and visible in the left side. That is in the near infrared region, 50% absorption and data will be reflected and 50% is absorbed. But in the visible region, most of the radiations are absorbed and less like a 5 to 8% uh, data is reflected. So the reflected in the near infrared is very much high. It is 5 to 6 times more. That's why the difference in the vegetation, visible and infrared, will clearly give the healthiness of the canopy cover and the forest areas. So it is a stress trees and it is a healthy tree. So in the stress tree, that is a 40% reflectance, and the absorption is 60%, and for visible lesion it is reflected in the 30%. So when the healthy trees like totally green cover vegetation is there, then in the visible region, the more spectrum is absorbed and less spectrum is reflected. Uh, and in the infrared, more spectrum is absorbed and more spectrum also reflected. But in the stress vegetation areas, the in the visible region, more absorb and some medium level is reflected. So these are the categories, and so by applying different band ratio, we can calculate what is the stress areas, what is the healthy area of these vegetations. Like also it is calculated in the cropland and forest areas, mangrove forest, scrub forest. So it can be calculated in different areas with respect to the different vegetations. So the formula for the normalized differential vegetation index (NDVI), that is a full form of NDVI, used for the health of vegetations in different areas. So it is the formula that is near infrared band minus red band divided by near infrared band plus red band. So it is increase in red shows stress vegetations and very near infrared shows chlorophyll. So what is the value? So generally NDVI value are ranging from -1 to 1. So is the dead plant or the dead objects are there. So its value is -1 to 0. Then, if the unhealthy plant or unhealthy croplands are there, then its value ranges from 0.0 to 0.33 or 0.35. It is ranging from this area. Then, when it is moderately healthy plant, then it is 0.033 to 0.66. And when it is a very healthy plant and it is evergreen forest or evergreen areas like mangrove areas, then its value will increase from 0.66 to 1. So using this value, we can calculate the what is the vegetation's health, what is the condition of the health of these vegetations in different seasons. So this is the indicator. The value indicates the healthiness of the vegetations in terms of the NDVI calculation. So this is one of the images which the average NDVI of June 2003 is look like this, and for NDVI in the October is look like this. So in the June there is a healthy vegetation due to the monsoon and other factors, and in the dry time there's the leaf shadings are there and other factors are there. So the vegetation health is not good as compared to the June season. So basically, in the monsoon season, the vegetation's health or forest health is will be more as compared to in the November and December or in the January February. So we can calculate the different aspect using this indices. So we just take one Lancet data. So different bands are there, like Lancet operational land imager. So it is downloaded from USGS site. So these are the bands 1 to 11 bands. Then infrared TRS bands are there. So from band 1 to band 7, there is 30-meter spatial resolutions, and one band that is panchromatic, that is resolution is 15 meter. Then band 9 is 30 meter, and band 10 and band 11, these are thermal infrared bands, which are useful for the uh, temperature analysis of surface temperature. So urban areas temperature or rural area temperature. So these are 100-meter resolution. So for our different NDVI calculations, we just take a band 2, 3, 4, 5, 6. So these are the bands, and their spectral wavelength is zero point 0.4 to zero point 0.5. So gradually the bands will bandwidth is will be increases from blue to south of infrared. So we just take band 5 and band 4, because band 4 is the red and band 5 is near infrared. So near infrared minus red by near infrared plus red, that is NDVI, which is calculated recently. So this is the formula: NDVI calculation, near infrared minus red plus near infrared plus red. So in this near infrared, in this our satellite image, the near infrared band is band 5 and red band is band 4 for Landsat 8 image. So in Landsat other images, the bands are different. So according to this, we can calculate the NDVI value. So this is our formula. So just go to the. So we have Lancet 5 image, band 5, and Lancet 4. These are two images are presented in our. So their resolution is 30 meter. So during calculation of NDVI or other indices, the resolution of this spectral bands will be same. So it is, I think, we can measure it. This is 30 meter. So it is look like 30-meter resolution. And this spectral pixel value is 12,000. So it is a value, that is the DN value of this spectral band. This all satellite image are 16 bit, 16-bit satellite image. It means 2 to the power 16, that the resultant will be 65,600 something is there. So maximum value is 65,000 something and minimum is 0. So within this range, the different uh, gray value are arranged from black to white. So total white is 65,600 and Total black is 0. So these are the gray value variations. So we have to calculate the NDVI now. So in the RGS, we have to go to the spatial analysis tool in our toolbox. Then raster calculate in map algebra. It is a raster calculate is there. Then go to the raster calculate. Then different bands are shown. So we just need only band 5 and band 4, and the formula is band 5 minus band 4 by band 5 plus band 4. So we can calculate using plot. So in this calculation we just need another term, that is plot, because these are all in the integer value. So we just add some float data. So our calculation is then 5 minus 4 divide by float 5 plus 4. This is our formula. Infrared minus red divided by infrared plus red. So just go to the output raster, then save L8 NDVI. We have to save it. Okay. So the processing is going on. This is our NDVI value of these areas. So it is arranged from -1 to 1. So we have to create and color RAM. So this is our NDVI. So green patches are more healthy vegetations are there. Some vegetations areas are in the green part because the high value is in the green part, low value is the red part. So these are red parts are non-vegetated area or straight vegetated area. The water bodies are also in the NDVI values. The water bodies values are near to the -1. So we can check it is pixel value is 0 point minus 0.08. So water bodies have low value, and in the green region, in the forest area, it is 0.33. It is 0.28. Then it is 0.25. So some mangrove area are also there. These are the mangrove forest. So in the mangrove forest, the NDVI value will be very high because it is a evergreen forest, evergreen tree also. So it is 0.31. It is 0.29. It is 0.26. So it is more than 0.25 in the mangrove forest areas. 0.33, that is the result. But in the water bodies, it's less than 0. It is 0.03. And in the sandy area also, It is very less, 0.13. So we can classify this NDVI value into 10 class or 15 class or 20 class. We can get the color ramp. So in this area, the blue color is very much high vegetative index area. So these are the values categorized from -1 to 1. We can give it in interval also, different same interval, equal interval. But it's not looking. We can define an interval. Interval size will be -2, 0.3. So this is the NDI classification. So based on this, we can know the different vegetative areas and non-vegetative areas, and the which areas have the highest vegetative uh, health conditions are there. So we can color it in unique color. I just give it into black, and it is not working here because 0.49 to 1 is not present. That's why it is not giving the result. So the value of 0.38 to 0.49. So is it available or not? Just taking it. It is also very less areas are there. So these are the areas. Then we can just check. So 0.34 to 0.38 is which is very high healthy vegetation of the area. So these are the Sonipal Reserve Forest National Park. These are the some vegetations which are present having the very healthy vegetations. So likewise, we can categorize it into different areas, which area are very healthy vegetations and which are not present. So this is one of the NDVI indices. So next is soil adjusted vegetation index. So this is also one of the method is there. You can calculate by applying this technique. Then MSAB, that is modified soil adjusted vegetation index. The ratio between the red and infrared value with the inductive L functions is there. So applied to maximize the reduction of soil effect on the vegetation signals. Then NDWI, that is normalized difference water index. So it is a green by near infrared, then green plus near infrared. So it is a band 3 minus band 5. Just calculate this, band 3 minus band 5. So we have band 3, that is band 3 and band 5. It is band 5. So in your examination, final examination, the practical examination. So minimum one NDVI or NDBI or NDWI indices are will be asked, because previously all of the exam these are already uh, given. NDVI or NDWI, one indices, then supervised and unsupervised classifications using different satellite data. So I will take class of this and supervised and unsupervised in the next class, and some convolutions and some band ratio. These are also sometimes asked using providing some satellite data. So this type of data are provided to you. Some bands are there. So using this band, you can to calculate different band ratio and NDVI value. So after that, you give the result and take the picture and give to the submit to this internal. So after all, then we are in the NDWI, that is normalized difference water index, green minus near infrared. So we have to same type of formula is there. Green is band 3, band 3 minus band 5, band 3 minus band 5 divided by port band 3 plus band 5. So it is a way to store data. NDWI, NDWI, L8, L8. So this is the value. So this is NDWI also created. Then you just give the color. So just give the color. Then the highest value which is shown in these areas is in the blue, dark blue, or you can take it in the, this is the color you can take. So this is our water bodies in this satellite image. So in the NDWI, the the higher indices are the water bodies, and lower indices are other than the water bodies. So I think just take it. So the pixel value is 0.1, then 0.08. So we can classify it into five classes. So it will be, so these blue areas are the water bodies, and some swampy and sandy areas are also there. So these are in the cyan color. So these are the river. So you can extract it, and we can get the information about the water content area of this area. So this is the river. The value will be, I think, more than five classes, so that it is clearly demarcated. So these are our water bodies which are found in NDWI. So when we are using any type of indices, suppose NDWI for water index or for vegetation index or for built-up index. So what is the our target? The target is water bodies in NDWI, and for NDVI, that is vegetations. So which is our target? Then the target value will be very high. So in NDWI, the indices of water bodies are very high, so that it is demarcated in different color. But in the NDVI, the water values are very less, and in the vegetation's indices are very high. So based upon the target of our indices, so the value of this indices are very high. So in this area, the water value are very high as compared to other features. So like that, different indices are there. NDWI is there, NDBI is there, the normal differential built-up index. So some town area or some settlements area are clearly demarcated, and there is a and this is another vegetation index, that is EVI, is computed following these equations, that is G into NIR minus rate. So this also can be calculated using this raster calculator. And another thing is NDVI is there. I think NDVI formula is, I think, short wave infrared, that is minus near infrared. Okay. So in our data, short wave infrared is 6 minus near. That means 6 minus 5. So generally NDVI is highlighting the built up areas, urban areas or different constructed areas. So I just go to this side, then 6 minus 5, so it is present in the 6 area. 6 minus 5, raster calculator, float, 6 minus 5 divide by float 6 plus 5. This is our formula for NDVI. NDVI, normal differential built up index. So just see what is happened to this satellite image. So this is also our image, so that we can change our color. That is not possible in this color range, so maybe this. No, I think this is, so we have to classify it in 10 different colors. So it is a town area. I think it's not working like it's shortwave infrared band NDVI. I think NDVI is mid infrared minus near infrared. Okay, okay. So this is our mid infrared band 7. Band 7 is not there. So to add data, band 7. So band 7 by band 5. This is the NDVI. So these are the settlements. We can use the. So these are the settlement areas, which is shown in the Google image. So in the NDVI value, the green colors are the NDVI, the built-up index. So it looks like these are the index. These are the settlement. And some industrial area also, the NDVI value is very high. This is the settlement areas. Likewise, we can create different indices, NDVI, NDVI. So all a lot of indices are there. So based upon the available data, we can get different indices using Landsat 8 band, then Sentinel data, Landsat 7 data, List 4 data also we can use, but it is not available free of cost. You can, if you have any LAN list for image, then it is clearly visible all the indices. Then principal component analysis is there. So in the principal component analysis, different bands are correlations are there. So band 1 to band 2, then band 2 to band 3, the relation between the two bands in different dimensions. So in the one dimension or two dimension, what is the relation between these two bands, then in three dimension, in four dimensions. So different uh, aspects are there. So in b1 and b2, so this is the relationship, then this is one of the band, another band. So these are the linear orientations are there. So these are the principal component analysis, and this is one of the resultant satellite image. So this is original RGB images. So if we rotate in different dimensions, the orientation, the shape, size, and the relationships are different. So this is the principal component analysis. So this is look like different relationships. If we rotate or in a different dimension, then the relationship between the different bands are changes. So as the relationship changes, the image shows the different aspect of these images, so that we can differentiate different geological aspect, different mineral explorations are there. So different minerals are identified based on this decolorulation stretches, and we can found different boundaries of different minerals. So this is the RGB, then correlated image, that is principal component analysis in different dimensions. So it looks like this, so that it can be demarcated this area, flood areas, and the river basin areas, river uh, areas, which compared to this false color images. So it is demarcated and with different techniques. Then spatial frequencies. So in these two images, the black and white pixels are there, but in the second image, black, white, and some gray level images and pixels are there. So they are arranged in different small patches. So if the satellite image have only black and white information, then it is a high frequency image, and if it is segregated or it is spread in different gray shadings or with looking some smooth variations, then it is a low frequency image. So a lot of images having high frequency are there, and some of the low frequency are there. So zero special frequency, that is a flat image in which every pixel has the same value, that is all is white. So suppose one sandy area or desert area, so most of the pixels are white and most of the pixels are near to the same value, that is white, than in the snow area also. So there is no variations in the pixels, that is called zero special frequencies. And in the low special frequency, that is image consists of smooth varying grayscales, like in the cropland areas or near the valley areas or in the coastal areas. A lot of vegetations of lot of features are there. So the pixels informations are very smoothly, as it is different features are reflected and absorbed with different amounts. So the spatial frequencies are very low. Then high special frequencies are, suppose there is a water bodies and there is this mm, uh, sandy area. So only water and sand. So sand reflects more, and water absorbs more. So there is a high reflectance value is there. Then another is high absorption values are there. So high absorption means there is a black pixels, and the high reflectance means there is a white pixels. So that's why the variations in these areas are very low. That's why only white and black pixels are there. So there is no smooth frequencies are there in between these areas. That's why it is called as high frequency areas. So depend upon the different landscapes, there are three type of frequencies generally occur, that is zero special frequencies, low special frequencies, and high special frequencies. That's why sometimes there is a error also occur. That is, some areas have more than high frequencies. So that time we have to get some special filtering techniques are used, some for some areas. And that special filtering process for dividing the image into these constituent special frequencies. The process of suppressing certain frequencies and passing. These techniques also increase the analyst's ability to discriminate details and where the low and high frequency is there. So this is a low frequency areas in the river bed areas, but in the forest area, in the Himalayan area, there is a high frequency areas because it's totally red color. So most of the pixel are near to same value. That's why it is high frequency value. So convolution process is there, that is a filtering technique. So it evaluating the weighted network pixel value located in particular spatial pattern around different location, different position of the input image. So techniques like mask window is placed over part of image, then convolution formula is applied over the different part of the weighted product, and coefficient of mass and raw dn values divided by some coefficients are there, and central value replaced by the output value. So some, if the high frequencies values are there in an image, so convolution process which constitutes some pixel with some kernel 3 into 3 or 5 into 5 is just like a matrix value. So in the matrix there's some pixels values are there, so some value are corrected. If it is a high frequency, then it is corrected into moderate frequency, so that the features of this earth surface will look some clearly visible or for different applications. So it's not doing for all the image sites. So this is the convolution process. There is the matrix like structure, and all the boxes are pixel informations, and these are the each pixels having different names are there. So it is 3 into 3 kernel. It is called kernel. So suppose we have to change this areas of this pixel of this satellite image, then we have to give some filtering and take the original data. Then it is processed with some average value of the pixel. Then it is given with some formulas are there. So after getting this formula, we get the satellite image having clearly visible image. So low different softwares are there. Convolution filter, Explorer software is there. So this is our pixel values of that site. Then after convolution process, these values are converted into some weighted average value. After that, we get some different values. So this is our original image. Then it is after convolution process. Then this is our image. So different techniques are used to identify different features. So the pixel before filtering, this is the pixel informations. So after filtering, this is the image. So in these previous pixels, the most of the pixels are having same values, but after filtering, the values of different gray level are different. So it looks like more darker as compared to the previous pixels, and it is more brighter as compared to the previous pixels. So that the classifications are very much easy. Mm, So different filter types are there. That is low pass filter, the, which block high frequency details, has smoothing effect on image, and used for removal of noises are there, and removal of salt and pepper noise are just dot type of noise are there. So it is also removed by the low pass filter. Then blurring of image, especially at edges. So this is also used for filtering. So it's a very important part. So just go through this: the high pass filter and low pass filter. Then high pass filter is preserve high frequencies and remove slowly varying components, emphasizes fine details, used for edge detection and enhancement, and location where transition from one category to other category occurs. So just want to just remember all these things because it is very much important for the exam. The low pass filter, there's the different kernels: 3 into 3, 7 into 7, 9 into 9. So these are the resultant of different filtering. This is also a different kernel: 3 into 3, 5 into 5, 7 into 7. So when the kernel is more, the image quality will be differ because the more area will be affected. Then high pass filters are linear and non-linear. Background is lost sometimes. So these are the applications and high pass filters for different edges. And this is the original image. Then there is the edge detection. Then is the edge detection in the 5 into 5. So these are the applications in high pass filter image. Then data compression is one of the topic is there. So how to store different satellite image in different formats are there. So satellite image compression is a process that reduces the size of satellite image to manage storage space and communication bandwidth. It is an important part of the satellite image processing and is followed. So generally, our satellite images are saved in TIFF format, tagged imaging file format, JPG format, joint export photographic uh, JPG format. then photographic group, and IMG format, then TIFF format, then JPG format, and ADAS format. So generally we use TIFF format, and lot of the satellite images are in the TIFF format, and some of are in the IMG format. Most of satellite images are not in the JPG format. So in the TIFF format, the data are compressed, and in the IMG format, the data will be more memory. So more data, increased storage, more data will be stored in the satellite mass memory. So depend upon the satellite resolution. Suppose we have high resolution satellite image, so it takes more memory. So more than 10 times or 15 times as compared to the 10-meter resolution satellite image. And for radar image like uh, average data or other uh, radar image is taking more than 200 GB of memory that is required. So this is the compressions can be transmitted to ground station more efficiently, better sharing. So share over the internet. All the images are stored in the row and column wise, and data is classified as continuous. And lot of techniques like lossless compression, lossy compressions, a lot of techniques are there. So it is not required for exam. So just go through this. Then pyramid way of showing the satellite image. So pyramids are reduced resolution representation of data sets and used for improved performance. So when you open some satellite data, it will ask, so if you need for pyramid level or general level. So pyramid level give the clear view of the uh, image when we zoom it. So pyramids can speed up the display of raster data by retrieving only the data at a specific resolution that is required for the display. And the coarser level of resolution are used to quickly draw the entire data set. So this is the uh, low resolution image in a low scale image. Then after zooming in certain level, it's look like this. So after zooming another level, so it is look like, so pyramid level is there, that 0 to level 1, level 2, level 3. So it increase in a pyramid way, so we can give the clear view of the image with different pixel. So these are some points of resolution copy and some pyramid. What's the benefit and what the characteristic of the different pyramid level? So it is an example of pyramid structure when you open a satellite image that is TIFF format. So this raster just ask some command in the adjust software, that is this raster source don't have a pyramid or content encapsulated pyramid. So pyramid building may take few minutes. So if you want pyramid building, then you can click on yes, or if you don't want, then no. Then image classifications like different classification techniques are there. So we'll discuss all this in the next class. What is the supervised classifications? What is unsupervised classification? Basically, this is a machine learning technique. So it is previously used. So nowadays it is very much widely spread technique in all of the technologies. So in the remote sensing technology, so same machine learning techniques are used in all of the different sectors, which is used in this remote sensing technique, like supervised classifications and unsupervised classification. So there are different methods are there in different supervised classifications and in the unsupervised classification. So what do you mean the image classification? So we have to suppose we have to classify some water bodies or some forest areas in a particular district. So we don't need to digitize all these features. um, so it takes more time. So in the machine learning techniques, we can give the command to the system that these water bodies, these are the some water bodies. So these pixels having information of these water bodies, these pixels are some forest areas, and these pixels are cropland. So based on this pixel values, average pixel values, based on this tone texture, so the machine will classify all the district with the help of this uh, training data, and classify within a second the entire district areas. So for the classification, the expert who will run this software have some experience in this image classifications, so that the maximum error will be avoided. Because if you put some forest area into different cropland, then it will classify all the cropland as a forest. So this is the interpretation skill is needed, and after that it will classify accurately. And unsupervised classification is also there. So in this classification, suppose we have in the district there are maximum possible of 10 land use land cover. So we just give the command that there are only 10 class are there in this district. So just classify these 10 classes according to this the digital number and other values. So it is automatically classify 10 classes. So it is unsupervised. So it cannot be supervised by any expert. So it is automatically machine will classify. So after that classification, we just classify according to their color into different classes. So these are the basic information about the image classification. Then now we just close the session. The next class will be supervised classification, unsupervised classification, and some radar and microwave data if possible. Then I will show you how the different radar data are used for different applications. And so with other examples are there. Okay, then if you have any queries, then just ask. Otherwise, we will close this session. Okay, Samal Raj, you have any query?
No,
Hello.
sir.
Okay. So I just provide you this slide and go through this, and some techniques of this tools are also, if possible, then I will provide. And so just you have any idea about this NDVI previously, or now just to see it?
No, sir. This is MDA done in my PG times.
Okay, okay.
I
But
have
that
a bit
time,
idea.
that time the this satellite image are not there.
Yeah, yeah.
So
That time
Landsat
we use
7 or Landsat 5 are there.
8,
So
sir.
Landsat 8 is there, na?
Yeah, I completed my PG 2019.
Oh, 19 recently.
Yeah.
Okay. So okay, then these are our machine learning techniques.
Okay.
So these type of questions are maximum asked in the practical season. What is the NDVI and supervised and unsupervised classification, then filtering, and these are some, because they have some 2 3 bands data. Then you have to calculate some indices. So there is not any difficult practical is there. So just go through it, then it will be very easy for you. Okay, then we'll conclude this session and we'll see the next class with the other classification techniques. Okay, good night.
Good night, sir. Thank you, sir.